Welcome back to these lectures on deaf children's literacy. In today's lecture, I'm going to talk about a very specific topic, but one that's really important given what's been happening, and that is looking at the impact of cochlear implants on literacy. I just want to remind you about all the things that have been happening in the last decade and why these might impact on literacy. I want to tell you about the research looking at impacts on language, and then I want to try and explore the literature around literacy and consider why the impact of cochlear implants on literacy doesn't seem to be nearly as clear-cut as the impacts on language. So let's begin just by reminding ourselves about all the things that have been happening. As a researcher, it's a really interesting time to be looking at deaf children's literacy because of all the interesting things that have been happening. And we need to try and understand what sort of impact they're having for deaf children. Now, just to remind you, though I'm sure you don't need reminding, there are two really important things have been happening on the technological side. I always like to think that we're very, very lucky to be in countries which have good healthcare and plenty of money, because this has provided the opportunity for two things. First of all, newborn hearing screening, which I know you've been had for some while in Australia, and better aiding. Not only cochlear implants, but also, of course, hearing aid technology has really been improving. Since you're perhaps not aware of the UK context, I just wanted to let you know that because we have our wonderful National Health Service, the Health Service in fact provides implants for all children for whom they're suitable. So it's not a question at all of money, as it is in many other parts of the world. And of course, with universal newborn hearing screening, implants are being provided much earlier for children than they were when they first started. And the technology of implants is continuing to improve. Actually, that's of course a blessing. The children have the implants. It does make the research difficult to interpret because we always have to ask, well, okay, so when exactly are you talking about? Or what kind of technology was present when the children had their implants? And as I've already mentioned, we mustn't forget that hearing aid technology has more generally been improving. So I'm interested not only in cochlear implants, but also in hearing aids more broadly. I think doing research with deaf children is difficult enough anyway, because they are such a varied population. But when we turn to cochlear implants, so many different factors can actually affect the outcome. So there's the age of diagnosis of the hearing loss in the first place, and then the age of implantation. But of course the intellectual ability of the child is also very important here, whether the child has additional difficulties, what's going on at home, and of course what's going on at school. All of these things can have an impact, and so I think we need to think really carefully about what kind of children are we talking about when we're looking at cochlear implant studies. So I want to begin with the general question of whether cochlear implants have actually benefited children's language development. There are quite a large number of studies here. I'm just going to focus on a couple that I think give us a flavour of what people have found. This is a study, it's a UK study, and it was one that was done by people attached to the Nottingham Centre. Nottingham, in fact, was the first centre in the UK to do cochlear implants for children. And I know there are very close ties actually between the centre in Nottingham and the centres in Australia. And this was a study which was actually looking at the views of parents about what their children were doing in terms of communication. And I think that the figures here are really quite striking, because out of the 142 children where parents were asked, and this is at the time was virtually all of the children in the sample, 119 reported that there'd been a change in the modality of the child's communication following the implant. And 113 children out of 119 moved from signing to speaking, and only 6 from speaking to signing. And interestingly, this greater use of spoken language was very much led by the child what the child's preferences were, which the parents then followed. And just as a comment about this, I think this is really interesting, because what this is showing is that having signing early on doesn't at all preclude the development of oral language once the child has got the implants and they're working effectively. Now, when we look more directly at measures of language, we can also see, I think, some really striking changes in what is happening following implant. This study is actually looking at a video analysis of a child and mother interacting. And I think that the numbers here are really quite staggering when you think about it. So if you take a typical 3.5-year-old child chatting to mum in a 30-minute play session where they've got some toys they perhaps haven't seen before and they're looking at them, talking about them. On average, but of course huge amount of variability here, the children were producing 210 different words in this 30-minute session, and they were producing utterances that were 3 morphemes long. So that's hearing children. Orally educated deaf children of the same age, filmed in the same way, were producing an average of 35 words and utterances that 1.5 morphemes long. That's an extraordinary difference, the difference between 210 words and 35 words. Now, the question was, okay, so that was what the position was like before cochlear implants. What was it going to look like when you looked at children who had implants? So what the researchers did was to do the same thing on a group of children who had cochlear implants. Again, a 30-minute filming session. What they found was a dramatic change in the scope of the children's language. On every measure that they used, the language was significantly better than it had been before. And here's the one I particularly like. At the bottom you can see there that the mean vocabulary score was 362 words. And remember how low it had been before. So this is a very dramatic increase. This study, I think, doesn't stand on its own because many other studies have found very similar things, that cochlear implants have really noticeable benefits for children's spoken language. So let's have a look at some more research from the same group. And they did a long-term follow-up of 85 adolescents who'd had implants when they were young, roughly around the age 2 to 3 years. And what they found was that speech perception and language skills were continuing to develop. So it wasn't just it was affecting things early on and then it stopped. That development was continuing right through secondary school. However, they did find, interestingly enough, that the children who were orally educated weren't necessarily showing an advantage when they got into secondary school. But this study is one of the first studies to hint that maybe there's something different with reading, because what it found was that the reading skills were not commensurate with the language skills. And I think this has been a recurring theme, that the results of studies looking at literacy outcomes following cochlear implantation have been very variable. I want, however, to give you a flavour of how well things can go, because I had the great fortune to be involved with the implant team in Nottingham. And we were able to look at the long-term literacy outcomes in the children who they'd implanted. There's quite an interesting methodological issue here, because the sample that we started out with had 105 children in it. When we looked at this children, though, in detail, what we found was that quite a number of these children had relatively lower IQs, and I felt it was very important, and in looking at literacy outcomes, what we did was focus on the children who had normal intellectual development, because we felt that these were the children who were going to show the greatest benefits from reading. You can see quite a range in the age at implantation, and in fact age at implantation was, as many other studies have found, related to a number of outcomes. But let me show you what we found for reading. Now, the children varied quite a lot in age, so a simple way to look at reading gains is actually to calculate their net reading age. So what you're doing here is you're comparing their reading age with their actual age. And children will have a positive score if their reading age is actually better, higher than their chronological age, and a negative score if it's lower. So remember, if you're above the line, above the 0 line, that means you're reading better than chronological age, and if you're below, it means you're reading at a lower level. So let me show you what we found. Okay, so you can see on this graph what we found. Remember, the children falling above the line are reading better than their chronological age, and falling below, they're reading less well. And you can see for the children who had an early implant, they were actually reading better than their chronological age. But the children who'd had a later implant were actually not reading as well. And this was at both 5 and 7 years post-implant. And you might wonder at this point, or worry about it even, what do we mean by an early implant here? Well, remember, this study was done quite a long time ago, because it's taking all of the children who've been put through the cochlear implant programme in Nottingham. And actually, an early implant was 42 months, which by the standards of today is actually relatively late, because we've got a lot of implants at 2 and under. So we found in this study that the children who'd been implanted before 42 months actually were reading at an age-appropriate level. So this was really very pleasing to find this, because although I'm a researcher, I do care very passionately about how well deaf children are reading, because it's really, really important in our complex society. Being functionally literate's the key to so many things. However, when we looked at some more data of children in secondary school, we found a rather less pleasing outcome. Because in this study, we actually compared children who had hearing aids with children who'd had either an early implant or a late implant. You can see there information about how old they were, essentially their adolescence. You can see age of diagnosis, which of course has come right down, because we've got children, some of whom will have been going through newborn hearing screening, and non-verbal IQ. And this is what we found about reading. And you can see, first of all of those scores are negative. So that means none of the children on average were reading at an age-appropriate level. And when we first got these results, we thought we'd done something wrong with the analysis. We reran it just to double check that we hadn't coded our sample incorrectly. But what you see is what we found. Actually, the children who were reading best out of the 3 groups were actually the children with the hearing aids. Our results about problems occurring and continuing to get worse in secondary school have been found by numbers of other researchers. So this is a summary of the study by Anne Gears and colleagues, where they did a long-term follow-up of quite a large group of children with cochlear implants. And you can see, I mean, some of them are doing okay. About half of them are reading at an age-appropriate level. But of course, what that means is that over half of the children aren't. Still significant problems with reading. Interesting, the spelling scores were slightly better than the reading scores, but still a lot of children not spelling very well. But here we find that phonological coding scores don't seem to be that good in many of the children. And it's really noticeable in this study that it's one of the first studies to flag up the fact that there might be still issues around the children's phonological coding. And in fact, in the study where we've been collecting the data right now, and we're just in the last stages of the analysis, where we are comparing children now with a group of children we saw 10 years ago, and you can look there and you can see they're similar in age, similar in age in unaided loss. Aided loss, of course, very much better as a result of the improved technology. What we found there was that there was no improvement at all 10 years later with a group of children who'd had all the benefits of newborn hearing screening and much earlier intervention, and many had got cochlear implants. If not, they had digital hearing aids. No impact on reading, it wasn't better. No impact on phonological awareness, it wasn't better, but language definitely was. Really, just to sum that up, what our data was showing, that it was really only English language that had improved. I think bringing together all of the different studies that have been done in many parts of the world, we can say there is very consistent evidence about cochlear implants having a really positive impact on language. And in fact, as we know now, many children who are deaf don't sound deaf anymore, which of course may bring its own problems. But many of the children are not making the reading progress that we might hope. So we can then ask the question, well, can we understand maybe what's going on here? And are there possible limitations to cochlear implants? Now, the answer to this question is just beginning to emerge. But we need to think a bit about what's going on in speech perception. And of course, the thing about speech, and here's an example of a spectrograph of the question, how are you? Speech, of course, is all about processing, moving information about critical frequencies in the spoken language. And of course, identifying the formats which are changing as somebody's talking. Okay, so some very recent work from Nitrawa and her colleagues is beginning to cast some light on what might be the issue for children with cochlear implants. And what she suggests is that it's this time-varying format structure of speech, which of course is very rapidly changing, that might be particularly difficult for deaf children to have access to. And of course, it's this kind of information that's absolutely crucial for being able to identify individual phonemes and particular words. And one way in which she has been trying to address this is by producing synthetic sine wave speech. Because the thing about sine wave speech is that it actually captures the properties of time-varying format structure. So what she's been trying to show is if you use this kind of model of representing speech, does it actually help matters? And so what she did was she got children with cochlear implants and with normal hearing listening to different kinds of sentences, either sentences that made sense or sentences that didn't, in noise or in a sine wave version. So she's comparing, as it were, something that's more like what the cochlear implants have now with something that's produced using the sine wave structure. And she found that the sine wave form of representing the sounds did actually seem to make the understanding of the sentences much easier. But interestingly, she found that the children's phonemic awareness was actually related to their ability to perceive this sine wave speech. And what Nitrawa has suggested is that if the speech processing algorithms that are used by cochlear implants can be better designed to capture the time-varying format structure of speech, then she thinks that this will help children develop much better phonological processing. So I think this is a really interesting question for the future. Will cochlear implants, and almost certainly I think the answer to this question must be yes, will they develop in such a way that they're actually going to help children get a much better understanding of the way that phonology works? Because the argument would be that if they can do this, then they're actually going to have the skills that they then need for reading. So we're coming towards the end now, and I just want to sum up. So first of all, cochlear implants definitely benefiting spoken language. Many, many studies, very consistent findings. Yes, clear-cut impacts. But although there are some notable exceptions, and interestingly, I think these are often from children who are part of rather carefully nurtured cohorts from cochlear implant teams who probably are getting optimal support from teachers of the deaf and speech and language therapists. Many children with cochlear implants are not making particularly good progress in reading, and certainly not as much as might have been hoped for, and that the differences or the difficulties seem to be particularly notable as children go into secondary school. And then it looks as though poor phonological skills seem to be a key component in why the benefits to language aren't translating into reading. Because it looks as though cochlear implants are not as good as they might be in providing information about time-varying format structure of speech, which is so important for developing phonological skills. So I've given you here some of the key references. Again, some of these arguments are quite tricky, but I think they're really fascinating papers and well worth some time to read them. Thank you for watching this lecture, and I look forward to seeing you. Well, I wish I could see you, but unfortunately I can't, for the next lecture, which is going to be on speech reading.